Section 760.5060 of the National Electrical Code addresses the specific requirements for the installation of audio system circuits within fire alarm systems, particularly those used for voice evacuation. It's imperative to understand the scope and implications of this section to ensure the safety and reliability of the fire alarm system. The core of 760.56D focuses on preventing the mixing of different types of electrical circuits within the same conduit or raceway. Specifically, it prohibits audio circuits that are installed using Class 2 or Class 3 wiring methods as defined in 725.54 and 725.61 from sharing the same cable or raceway with power-limited fire alarm wiring, otherwise known as PLFA. To fully grasp the significance of this requirement, let's break down the key elements. Firstly, audio system circuits as described in 640.9c. This refers to the circuits that carry the audio signals used for voice evacuation messages within the fire alarm system. These messages are crucial for guiding occupants to safety during a fire or other emergency. Secondly, Class 2 and Class 3 wiring methods. These are defined in Article 725 of the NEC and relate to power-limited circuits. Class 2 and Class 3 circuits are designed to limit the voltage and current to reduce the risk of electrical shock and fire. The specific requirements for these classes of wiring are detailed in 725.54 and 725.61. Thirdly, power-limited fire alarm circuits or PLFA. These circuits are used for the primary functions of the fire alarm system, such as detecting smoke or heat, initiating alarms, and transmitting signals to the fire department. Like Class 2 and Class 3 circuits, PLFA circuits are also power limited to enhance safety. The primary reason for the separation requirement outlined in 760.56d is to prevent a fault in one circuit from affecting the operation of the other. For example, if an audio amplifier circuit malfunctions and comes into contact with a PLFA circuit within the same conduit, it could potentially introduce noise or interference into the fire alarm system. This interference could then impair the system's ability to detect fires, activate alarms, or transmit signals properly. By keeping these circuits separate, the risk of such interference is significantly reduced, ensuring that the fire alarm system can function reliably even in the event of a fault in the audio system. The 2005 NEC introduced Section 760.56d, and the rationale behind this addition was to address a specific concern about the potential for audio amplifier circuits to interfere with the power-limited fire alarm circuits. An audio amplifier is designed to boost the audio signal so that it can be heard throughout the building. The audio signal needs to be loud enough and clear enough so people can hear it. However, in the event of a fault, the audio amplifier circuit could potentially introduce unwanted signals or voltage into the fire alarm circuit, which is why the NEC requires the separation of the two circuits. Now let's consider some practical implications of this requirement. When installing a fire alarm system with voice evacuation capabilities, you must ensure that the audio circuits and the PLFA circuit are run in separate conduits or raceways. This means that you cannot bundle these wires together or run them through the same protective enclosure. In some cases, it may be permissible to use a cable with separate shielded compartments for the audio and PLFA circuits, as long as the shielding effectively prevents interference between the circuits. However, it is crucial to verify that such a cable meets the requirements of the NEC and any applicable local codes. It is also important to note that this requirement applies specifically to audio circuits that are installed using Class 2 or Class 3 wiring methods. If the audio circuits are installed using different wiring methods, such as those covered in Article 640 of the NEC, the separation requirement may not apply. However, it is still good practice to keep these circuits separate whenever possible to minimize the risk of interference. In addition to the separation requirement, it is essential to follow all other applicable requirements of the NEC when installing fire alarm systems. This includes proper grounding, bonding, overcurrent protection, and wiring methods. By adhering to these requirements, you can ensure that the fire alarm system is installed safely and reliably. To summarize, Section 760.56d of the NEC prohibits the installation of Class 2 or Class 3 audio circuits in the same conduit or raceway with power-limited fire alarm wiring. This requirement is intended to prevent a fault in one circuit from affecting the operation of the other and impairing the fire alarm system. When installing fire alarm systems with voice evacuation capabilities, it is crucial to follow this requirement and all other applicable requirements of the NEC. Now, let's delve deeper into the specifics of Class 2 and Class 3 circuits and their relevance to fire alarm audio systems. Class 2 and Class 3 circuits are defined in Article 725 of the NEC as power-limited circuits. This means that the voltage and current in these circuits are restricted to certain levels to reduce the risk of electrical shock and fire. The specific voltage and current limits for Class 2 and Class 3 circuits are outlined in 725.21 and 725.24, respectively. Class 2 circuits are generally considered to be safer than Class 3 circuits because they have lower voltage and current limits. However, both types of circuits are widely used in fire alarm systems for various purposes, including powering initiating devices, notification appliances, and control circuits. When using Class 2 or Class 3 circuits for audio systems, it is essential to select components and wiring methods that are appropriate for the voltage and current levels involved. This may involve using shielded cables, surge suppressors, and other protective devices to minimize the risk of electrical noise and interference. In addition to the voltage and current limits, Class 2 and Class 3 circuits are also subject to other requirements outlined in Article 725 of the NEC. These requirements cover topics such as overcurrent protection, wiring methods, and grounding. It is crucial to comply with these requirements to ensure that the circuits are installed safely and reliably. Now let's turn our attention to Article 640 of the NEC, which covers audio signal processing, amplification, and reproduction equipment. This article provides requirements for the installation of audio systems, including those used for voice evacuation in fire alarm systems. Section 640.9c, which is referenced in 760.56d, specifically addresses the wiring of audio system circuits. This section requires that audio system circuits be installed in accordance with the requirements of Chapter 3 of the NEC, which covers wiring methods and materials. This means that you must use appropriate wiring methods such as conduit, cable trays, or raceways to protect the audio system wiring from physical damage and environmental factors. In addition to the wiring method requirements, 640.9c also requires that audio system circuits be grounded in accordance with the requirements of Article 250 of the NEC. This is important for preventing electrical shock and minimizing the risk of electrical noise and interference. When installing audio systems for voice evacuation, it is also crucial to consider the requirements of other applicable codes and standards such as the National Fire Alarm and Signaling Code, NFPA 72. NFPA 72 provides comprehensive requirements for the design, installation, and maintenance of fire alarm systems, including voice evacuation systems. This code covers topics such as audibility, intelligibility, and emergency power. By complying with NFPA 72, you can ensure that the voice evacuation system is effective in alerting occupants to a fire or other emergency and guiding them to safety. In addition to the technical requirements, it is also important to consider the human factors involved in voice evacuation systems. The messages that are broadcast over the system should be clear, concise, and easy to understand. The system should also be designed to provide adequate coverage throughout the building, ensuring that everyone can hear the messages. Regular testing and maintenance of the voice evacuation system are also essential for ensuring that it is functioning properly. This includes testing the audibility and intelligibility of the messages, as well as checking the emergency power supply and other critical components. Now let's consider some common scenarios where the separation requirement of 760.56d would apply. Imagine a large office building with a fire alarm system that includes voice evacuation capabilities. The audio system is used to broadcast messages instructing occupants on how to evacuate the building in the event of a fire. The audio system circuits are installed using Class 2 wiring methods, and the power-limited fire alarm circuits are used to connect the smoke detectors, pull stations, and other initiating devices. In this scenario, 760.56d would require that the audio system circuits and the power-limited fire alarm circuits be run in separate conduits or raceways. This would prevent a fault in the audio system from interfering with the operation of the fire alarm system. Another example would be a school with a fire alarm system that includes voice evacuation capabilities. The audio system is used to broadcast messages instructing students and staff on how to evacuate the building in the event of a fire or other emergency. The audio system circuits are installed using Class 3 wiring methods, and the power-limited fire alarm circuits are used to connect the fire alarm control panel to the various devices throughout the building. In this case, 760.56d would also require that the audio system circuit and the power-limited fire alarm circuits be run in separate conduits or raceways. In both of these scenarios, the separation requirement is essential for ensuring the reliability of the fire alarm system and the safety of the building occupants. By keeping the audio system circuits and the power-limited fire alarm circuits separate, you can minimize the risk of interference and ensure that the fire alarm system can function properly even in the event of a fault. Now let's explore some of the exceptions to the separation requirement of 760.56d. While the general rule is that audio system circuits and power-limited fire alarm circuits must be run in separate conduits or raceways, there are some situations where this may not be required. One exception is when the audio system circuits and the power-limited fire alarm circuits are installed in a cable with separate, shielded compartments. If the shielding is effective in preventing interference between the circuits, it may be permissible to run the circuits in the same cable. However, it is crucial to verify that the cable meets the requirements of the NEC in any applicable local codes. Another exception is when the audio system circuits are installed using wiring methods that are not classified as Class 2 or Class 3. In this case, the separation requirement of 760.56d may not apply. However, it is still good practice to keep these circuits separate whenever possible to minimize the risk of interference. It is important to note that these exceptions should be applied with caution and only after careful consideration of the potential risks involved. In any situation where you are unsure whether the separation requirement applies, it is always best to consult with a qualified electrical engineer or inspector. Now let's discuss the importance of proper documentation and labeling when installing fire alarm systems with voice evacuation capabilities. Proper documentation and labeling are essential for ensuring that the system can be easily maintained and repaired. When installing the system, it is important to create detailed wiring diagrams that show the location of all circuits, devices, and components. These diagrams should be kept in a safe and accessible location such as the fire alarm control panel room. In addition to the wiring diagrams, it is also important to label all circuits, devices, and components clearly and accurately. This will help technicians to quickly identify and troubleshoot problems when performing maintenance or repairs. The label should be durable and resistant to environmental factors such as moisture and temperature changes. When labeling the circuits, it is important to indicate whether they are audio system circuits or power-limited fire alarm circuits. This will help to ensure that the separation requirement of 760.56d is maintained. It is also important to label the conduits and raceways that contain the circuits. This will help to prevent accidental damage or modification of the circuits. Proper documentation and labeling are not only important for maintenance and repairs, but also for inspections and audits. When the fire alarm system is inspected by a qualified inspector, they will use the documentation and labels to verify that the system is installed in accordance with the applicable codes and standards. In addition to the technical aspects of installing fire alarm systems with voice evacuation capabilities, it is also important to consider the legal and regulatory requirements. Fire alarm systems are subject to a variety of codes and regulations at the federal, state, and local levels. These codes and regulations cover topics such as design, installation, testing, and maintenance. It is crucial to comply with all applicable codes and regulations to ensure that the fire alarm system is legal and safe. Failure to comply with these requirements can result in fines, penalties, and even criminal charges. In addition to the codes and regulations, there may also be insurance requirements that apply to fire alarm systems. Insurance companies may require that the system be installed and maintained in accordance with certain standards, such as those published by the National Fire Protection Association, NFPA. It is important to check with your insurance company to determine what requirements apply to your fire alarm system. Now let's delve into the specific types of wiring methods that are commonly used for audio system circuits and power-limited fire alarm circuits. The NEC provides a variety of wiring methods that are suitable for these applications. Some of the most common wiring methods include conduit, cable trays, and raceways. Conduit is a rigid metal or plastic tube that is used to protect and route electrical wiring. Conduit is available in a variety of sizes and materials, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. Conduit is a good choice for applications where the wiring needs to be protected from physical damage or environmental factors. Cable trays are open metal or plastic structures that are used to support or route electrical cables. Cable trays are available in a variety of sizes and materials, including ladder cable trays, trough cable trays, and channel cable trays. Cable trays are a good choice for applications where there are a large number of cables that need to be routed together. Raceways are enclosed metal or plastic channels that are used to protect and route electrical wiring. Raceways are available in a variety of sizes and materials, including surface metal raceways, underfloor raceways, and cellular floor raceways. Raceways are a good choice for applications where the wiring needs to be concealed or protected from physical damage. When selecting a wiring method for audio system circuits and power-limited fire alarm circuits, it is important to consider the specific requirements of the NEC and any applicable local codes. The wiring method must be suitable for the voltage and current levels involved, and it must provide adequate protection for the wiring. It is also important to consider the environmental conditions in which the wiring will be installed. For example, if the wiring will be exposed to moisture or corrosive chemicals, it is important to select a wiring method that is resistant to these factors. In addition to the wiring method, it is also important to select the appropriate type of wire or cable for the application. The NEC provides a variety of wire and cable types that are suitable for audio system circuits and power-limited fire alarm circuits. Some of the most common wire and cable types include copper conductors, aluminum conductors, and fiber optic cables. Copper conductors are the most common type of wire used for electrical wiring. Copper is a good conductor of electricity, and it is relatively resistant to corrosion. Aluminum conductors are less expensive than copper conductors, but they are also less conductive and more susceptible to corrosion. Fiber optic cables are used to transmit data and signals over long distances. Fiber optic cables are immune to electrical noise and interference, and they can transmit data at very high speeds. When selecting a wire or cable type for audio systems circuits and power-limited fire alarm circuits, it is important to consider the specific requirements of the NEC and any applicable local codes. The wire or cable must be suitable for the voltage and current levels involved, and it must provide adequate insulation and protection. It is also important to consider the environmental conditions in which the wire or cable will be installed. Now let's shift our focus to the importance of grounding and bonding in fire alarm systems with voice evacuation capabilities. Grounding and bonding are essential for preventing electrical shock and minimizing the risk of electrical noise and interference. Grounding is the process of connecting electrical equipment to the earth. This provides a path for fault currents to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Bonding is the process of connecting different metal parts of an electrical system together. This helps to equalize the voltage between the parts, which reduces the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding in Article 250. These requirements cover topics such as grounding electrodes, grounding conductors, and bonding jumpers. It is crucial to comply with these requirements to ensure that the fire alarm system is properly grounded and bonded. In addition to the NEC requirements, there may also be local codes or standards that apply to grounding and bonding. It is important to check with your local electrical inspector to determine what requirements apply to your fire alarm system. When grounding and bonding audio system circuits and power-limited fire alarm circuits, it is important to use separate grounding and bonding conductors for each type of circuit. This will help to minimize the risk of electrical noise and interference. It is also important to ensure that the grounding and bonding conductors are properly sized and installed. The size of the grounding and bonding conductors must be sufficient to carry the fault current that may occur in the event of a short circuit. Now, let's address the topic of overcurrent protection in fire alarm systems with voice evacuation capabilities. Overcurrent protection is the process of protecting electrical circuits from excessive current flow. Excessive current flow can damage electrical equipment and cause fires. The NEC provides detailed requirements for overcurrent protection in Article 240. These requirements cover topics such as circuit breakers, fuses, and overcurrent relays. It is crucial to comply with these requirements to ensure that the fire alarm system is protected from overcurrents. When selecting overcurrent protection devices for audio system circuits and power-limited fire alarm circuits, it is important to choose devices that are specifically rated for these applications. The overcurrent protection devices must be able to interrupt the maximum fault current that may occur in the event of a short circuit. It is also important to ensure that the overcurrent protection devices are properly sized and installed. The size of the overcurrent protection devices must be appropriate for the ampacity of the conductors that they are protecting. In addition to the NEC requirements, there may also be local codes or standards that apply to overcurrent protection. It is important to check with your local electrical inspector to determine what requirements apply to your fire alarm system. Now, let's discuss the importance of regular testing and maintenance of fire alarm systems with voice evacuation capabilities. Regular testing and maintenance are essential for ensuring that the system is functioning properly and that it will be effective in the event of a fire or other emergency. The NFPA 72 provides detailed requirements for testing and maintenance of fire alarm systems. These requirements cover topics such as visual inspections, functional testing, and sensitivity testing. It is crucial to comply with these requirements to ensure that the fire alarm system is properly tested and maintained. Visual inspections should be performed on a regular basis to check for any signs of damage or deterioration. Functional testing should be performed to verify that all of the components of the system are functioning properly. Sensitivity testing should be performed on smoke detectors to ensure that they are able to detect smoke at the appropriate levels. In addition to the NFPA 72 requirements, there may also be local codes or standards that apply to testing and maintenance. It is important to check with your local fire marshal to determine what requirements apply to your fire alarm system. When performing testing and maintenance, it is important to document all of the work that is performed. This documentation should include the date of the testing, the results of the testing, and any corrective actions that were taken. The documentation should be kept in a safe and accessible location such as the fire alarm control panel room. Now, let's consider some common problems that can occur in fire alarm systems with voice evacuation capabilities. One common problem is that the audio system may not be loud enough to be heard throughout the building. This can be caused by a variety of factors, such as improper speaker placement, low amplifier output, or excessive background noise. Another common problem is that the messages that are broadcast over the system may not be clear or easy to understand. This can be caused by poor audio quality, complex or confusing language, or inadequate training of the personnel who are responsible for broadcasting the messages. Another common problem is that the system may not be able to operate on emergency power for the required amount of time. This can be caused by a faulty battery, a damaged generator, or improper wiring. When troubleshooting problems in fire alarm systems with voice evacuation capabilities, it is important to follow a systematic approach. Start by gathering information about the problem, such as when it occurs, what symptoms are present, and what actions have been taken to try to resolve it. Then use the process of elimination to identify the cause of the problem. Once the cause of the problem has been identified, take corrective action to resolve it. This may involve replacing a faulty component, adjusting a setting, or rewiring a circuit. After taking corrective action, test the system to verify that the problem has been resolved. Finally, document all of the work that was performed. In conclusion, the installation of fire alarm systems with voice evacuation capabilities requires careful attention to detail and a thorough understanding of the applicable codes and standards. By following the guidelines and best practices outlined in this narration, you can ensure that the system is installed safely, reliably, and in compliance with all applicable requirements. This will help to protect building occupants and minimize the risk of fire and other emergencies.